This video is going to show how to perform Monte Carlo analysis automatically in PSpice Designer Plus to improve product yield. While it is possible to get close to ideal component values with tight tolerances and precision manufacturing, there will always be some deviation from the ideal values. As a result, the analysis of a circuit in the real world may yield different measurements than that of a simulation, and circuit operation may fall outside of the functional requirements. To predict how many boards may not comply with operational requirements due to component tolerances and improve product yield, Monte Carlo analysis can be performed during the schematic phase of the PCB design process. Start by opening the provided design in PSpice Designer Plus. Monte Carlo analysis works by varying component values within their specified tolerances and analyzing the circuit output. Let's define common tolerances in a parameter list. To place a parameter list, select Place Component from the menu. The Component Explorer tab opens. From here, you can place components with PSpice models assigned, as well as components from Symaxis, Ultralibrarian, and more. Expand the PSpice category and select Simulator Command Setup. Select Param from the parts list and double-click to attach it to your cursor. This is a parameter list that can be used to define global parameters such as common tolerances. Click to place the list in the schematic, then right-click and select End Mode. The list can now be used to define any global parameters for the design. To define a parameter, double-click the list. The Property Editor tab opens. All properties for the selected object are defined in the Property Editor tab. For a parameter list, this is where global parameters are defined as well. Select New Property to add a new parameter. The Add New Property window opens. Enter a name and value for the parameter. In this case, we'll set capacitor tolerance to 10%. Check the option for Display On/Off to show the property on the schematic canvas. Click OK. The Display Properties window opens. Here you can define how the property is shown on the component. Select Both if value exists to display the name and value and click OK. Now let's define the inductor tolerance. Select New Property again. In the Add New Property window, enter inductor tolerance for the name. We'll set the inductor tolerance to 20%. Check Display On/Off and click OK. Set the display format to Both if value exists and click OK. The component tolerances have been defined. Click Apply and close the Property Editor tab. The tolerance parameters are shown in the PCB canvas on the parameter list object. With the tolerance parameters defined, we need to assign them to the inductors and capacitor as well. Double-click capacitor C4 to open its Property Editor tab. Select the cell for tolerance and enter bracket CTOL bracket to assign the CTOL parameter as the component tolerance. Click Apply and close the Property Editor tab. Now let's assign the tolerance to the inductors. Hold Control on the keyboard and click inductors L1 and L2 to select them. Right-click one of the inductors and select Edit Properties to open the Property Editor tab for both inductors. To assign a property to both components, right-click the header cell and select Edit. The Edit Property Values window opens. Enter bracket LTOL bracket and click OK. Click Apply and close the Property Editor tab. Before we can run an automatic Monte Carlo analysis, we need to run a simulation for the design. A transient simulation has already been defined for this design and can be run by selecting PSpice Run from the menu. The PSpice AD window opens to show the simulation results. Monte Carlo analysis is typically used to analyze the yield of a specific measurement in the simulation. To define the measurement, select View Measurement Results from the menu. The Measurement Results subpanel opens. Select Click here to evaluate a new measurement to create a new measurement. The Evaluate Measurement window opens. For this example, let's analyze the peak output voltage. Select Measurements from the Functions or Macros drop-down at the top of the window. Select Max 1 from the measurement list. Select VVOut from the Simulation Output Variables list. The measurement is defined as Max VVOut. Click OK to save the measurement. The measurement has been added to the list and the value has been calculated. Close the PSpice AV window. Back in the schematic canvas, select PSpice Advanced Analysis Monte Carlo to run Monte Carlo analysis. If the PSpice Advanced Analysis Product Choices window opens, select the appropriate license and click OK. The PSpice Advanced Analysis window opens with the Monte Carlo panel. This is where the Monte Carlo analysis will be run. To import the measurement we defined earlier, click here to import a measurement created within PSpice. The Import Measurements window opens. Select Max VV out and click OK. The measurement is added to the list. Next, we need to configure profile settings. Select Edit Profile Settings from the menu. Here you can define the number of runs, starting run number, random seed value, and number of bins. Set the number of runs to 500 and click OK. With the measurement defined and imported and Monte Carlo analysis settings configured, we are ready to run the analysis. Select Run Start Monte Carlo from the menu. When the analysis finishes, view the probability density graph at the top of the window and statistical calculations at the bottom. The yield is shown to be 100% and the median value is around 32.41 volts. To view the cumulative distribution graph, right-click the graph and select MC Graph PDF CDF. The cumulative distribution graph is shown. Raw measurements from each run of the analysis can be shown here as well. Select the Raw Measurements tab to view the raw measurements. Quickly perform Monte Carlo analysis to evaluate and improve product yield in PSpice Designer Plus. For more tutorials, visit us at resources.ema-eda.com and don't forget to like and subscribe to our YouTube channel.